experiment is a little different than the ones we've done so far. We will be investigating how the enzyme catalase affects decomposition rate of hydrogen peroxide. Remember, enzymes are proteins that speed up reactions by lowering activation energy. To do this, we are going to be using 3 cups that each contain distilled water, catalase, and hydrogen peroxide. We're going to be dipping paper discs into the distilled water and the catalase, and then placing them in the cup containing hydrogen peroxide. Once they're in the hydrogen peroxide reaction cup, we are going to time how long the paper discs take to rise to the surface of the cup. If catalase is indeed an enzyme, it should decrease the amount of time for the reaction, and the paper disc should rise to the top of the hydrogen peroxide cup more quickly. So let's take a look and see what happens. So that all of you have a good view of what's going on, I'm going to stand off to the side, but I'll let you know what I'm doing as I do it. So first we want to pick up a paper disc. The first one I'm going to dip in distilled water. All right, so now that this is saturated with water, I'm going to get ready to start the timer. I'm going to place this paper disc at the bottom of the reaction cup that contains hydrogen peroxide. Once it's at the bottom, I'll start the timer. So our paper disc is right here. So keep an eye on it. We'll see if it rises to the top. If we wait for 2 minutes and nothing happens, we'll record 2 minutes as our time and move on to the next step. All right, now that 2 minutes has passed, we can move on to the next step. We see that this disc dipped in water never rose to the top. Let's try it one more time to see if our results are the same. And our paper disc this time is right here. Keep an eye on it, see if it rises to the top. All right, so this paper disc also did not rise to the top. So essentially, there is no reaction between the distilled water and the hydrogen peroxide. But for the sake of your calculations, you can record that these discs took 2 minutes to rise to the surface. All right, so now we are going to be doing the exact same thing, except we're going to dip the paper disc into the catalase. Once I put it at the bottom of the reaction cup containing hydrogen peroxide, I'll start the timer. And our disc is right there if you want to keep an eye on it. You might also notice there are some very tiny little bubbles in through here. The disc is starting to rise. And it's at the surface. All right, so it took a little over 22 seconds for that disc to rise. Let's do it one more time to see if we get the same results. All right, the paper disc is right there in the center. Keep an eye on it and wait for it to rise. And it's at the surface. So this one took a little bit longer, a little over 26 seconds, but still much quicker than the paper soaked in water, which actually didn't rise at all. From that experiment, we can see that enzymes do speed up rate of reaction. For the discs soaked in water, they actually didn't react with hydrogen peroxide at all. They stayed at the bottom of the cup. For those soaked in catalase, our enzyme, they quickly rose to the top. What you want to do now is record all of the data we collected, and then you're going to perform a calculation to determine the rate of speed at which each disc rose to the top of the cup. For simplicity's sake, you can use 2 minutes for the discs soaked with water. For those soaked with hydrogen peroxide, you'll use the amount of time recorded by the stopwatch. Once you have that information, you'll need to know the depth of the hydrogen peroxide, or the distance the discs traveled. I measured this before we got started, and it's 2 centimeters. You can use this information to calculate your rate, which is going to be d divided by t, or distance divided by time. So go ahead, record your data, perform that calculation, and if you need help, ask your instructor.